Welcome back. Spinal cord injuries result when there's a gap in the signal from the brain to the legs. At the Institute for Medical Research Israel, Canada, located at the Hebrew University of Jerusalem, Professor Aharon Lev Tov has found a way to bridge that gap and allow people to walk again. I visited the professor in his lab in Jerusalem to learn more. Professor, we're in your lab here, and you were doing some incredible work with spinal cord injuries. Patients have had injuries in their spinal cord. Explain what you're doing, because I think it's really revolutionary.
Well, the spinal cord is not a kind of a simple relay between the brain and the periphery. It contains special networks known as central pattern generators. These networks are in charge of generating the neural program that is required for swimming, walking, and running. Under normal conditions, these networks are controlled by the descending input from the brain.
Yeah, most of us understand the brain would send the signal, right?
Right. This is kind of a voluntary command that is sent from the brain to the network, and this way these pattern generators are activated, and there is the outcome is a kind of a coordinated movement. However, when the connectivity with the brain is impaired or partly
someone had an injury and your back has been broken or
something.
Exactly,
following spinal cord injury, then a sensory stimulus, sensory input from the leg that converge exactly to the same site of the connectivity from the brain.
Okay, hold on, I'm going to stop you there for a second.
Right.
What you're saying to me is that you found that a sensory stimuli somewhere on the body can actually send a signal back to the spine.
To the spinal cord,
activating the same
these pattern generators, and this way we can induce walking in spinal cord injury patients that are, of course, their body weight has to be supported. We're talking about a procedure known for the last few years as treadmill training, body weight supported locomotion. And actually, the input that is required is very simple. It comes from load receptors in your legs.
Right.
However, in our lab, we found that a special set of efferents coming from the sacral part of the body, we call them sacrocaudal efferents, are extremely potent in activation of this central pattern generators.
How do you know where on the body to stimulate to get that load to get that stimulates on the spine?
Right. I mean, normally, the load receptors are, of course, sufficient for the induction of this locomotor activity. However, we found that in addition to this, this specific set of efferents that we discovered, actually, we found them in experimental models in our laboratory work, are capable of inducing a very potent locomotor activity, and there are skin receptors that we can activate in the sacral region, and we can stimulate directly the sensory nerves that are associated with
what you're saying
receptors.
Is amazing, that by just stimulating on the skin, that's sending a signal to the spine to tell me to start walking.
This is correct.
Are you working with people that have been paralyzed who are starting to be trained to walk again?
Well, the people who are paralyzed and have incomplete spinal cord injury, incomplete thoracic injury of the spinal cord, after such a training, treadmill training of a few months, they can improve their mobility, walk with the appropriate support, and some of their motor functions are also improved. So it's extremely beneficial for these patients, but not for other type of patients. I'm not talking about cervical patients, and I'm not talking about spinal cord injury patients with complete spinal cord lesion, complete transection of the spinal cord. And there are some fringe benefits from this treatment: increase in the blood flow, increase in the muscle mass, decrease in absorption of the bone, that occurs usually.
Well, of course, once you're
injury,
stimulating the limbs to
build
move,
you
build the muscles.
Exactly.
It's not just atrophied limbs.
Exactly, like sport.
Right, right. Now, I understand that you've had a conversation with Rick Hansen. We know him in Canada really well.
Right.
Tell me about what he discovered and how he's working with you.
Well, I mean, Rick Hansen was here for a visit a few days ago, and we just had a short conversation, and we gave him some talks. We described our findings, and the general idea is try to get some support for mutual research projects with UBC, probably in the same field of research.
I mean,
So,
the hope that you could provide for people who, whose limbs have been not immobile, this is incredible. The research is really amazing.
Well, I hope so. I hope that we can help the patients and we can improve their mobility, and this is simply by teaching them how to use the hardware that is still functioning after the injury.
Wow. Thank you so much for having a conversation. All the best in your work.
Thank you.
Special thanks to the Canadian Friends of the Hebrew University of Jerusalem for hosting our trip. More P3 coming up next.